So Unit 4 is when we really sort of start more of the classical algebra stuff that we'll be dealing with, and we are here until May in dealing with true Algebra 2 topics, okay? So the first Unit 4 is something called piecewise functions. We'll talk about functions, domain, and range. Then we move into quadratics, and we will be there till Christmas. That is the biggest unit that we have dealing with quadratic functions. Algebra 1 is a lot about graphing lines. Algebra 2 is about graphing parabolas and quadratics and solving quadratics. So that's where we'll spend the biggest unit of the year after we get this one out of the way. So let's get some preliminaries out of the way here. We need to be used to expressing our answers in something we call interval notation. Okay, so you probably spent a lot of time in middle school dealing with inequalities, less than, greater than, less than, equal to, greater than, equal to. We want to express all of our numbers now in something we call interval notation. So what this means is, this is the set, I'll just sort of write this off to the side. This is the set of all numbers x such that x is greater than a and less than b. So math is full of like short little symbols that mean a lot of things. Okay, that's what these brackets mean, the set. You guys knew that already. The set of all x, these vertical lines, the set of all x such that, that's what the vertical line means, such that x is between a and b. So without me writing that, you could have probably deciphered that. It's all the numbers between a and b. We are not going to do a whole lot with number lines. That's something we do in middle school. But if this were a number line and it had all the values from a to b, this would be talking about every number in between a and b. Now, why did I draw open circles on a and b? Yeah, because a and b were not included in this answer. So that's what you did on a number line, but in interval notation, this is all the numbers from a to b, okay? Math is also famous for we use the same symbol to mean different things. You do this in English. Like if a word has two, if the word two shows up in a sentence, how do you know which two I'm talking about? What do you do? No, if I speak it, what is your clue? It's the context. Same thing here. Okay. When I'm talking about an interval, this means every number between a and b. If I were talking about points on a graph, what would that mean? Come on, guys. If I were talking about a graph and I said AB, what would I be talking about? That's the x and y coordinate of a point on the graph. So keep in mind, those mean the same thing, but in the context of an interval, that means every number between a and b. If I were graphing this, that might mean the point AB right there. That's what it might mean on the graph. So you have to look at the context, okay? What about every number that is greater than equal to A and less than B? So what that would look like is something like this. Every number that is greater than equal to A and less than B. What would that look like in interval notation? That's the interval from A to B. And we have different enclosures. What goes around the B? A parentheses. What goes around the A? Square bracket, okay? Like that. So a square bracket. So that is the interval notation that the A is included, but the B is not, okay? Without me drawing this one on a number line, this is AB. What are the enclosures? What goes around A? Parentheses, and around B, square bracket, okay? So that's every number greater than A, and at the same time less than or equal to B. And I'm going to not fill out number line every time, because really what we're after from this moment on in all of your math classes, we don't really want number line answers. We want interval notation. What is this interval right here? This is the interval from A to B with what kind of enclosures? Bracket and bracket on both of those, okay? So if I had that on a number line, that would be this scenario. All the numbers greater than equal to A, less than or equal to B. What about the set of all numbers that are less than B? Let me draw this one out. So if a number is less than B, that means it's an open circle. Which way do I shade to get the numbers that are less than B? Left or right? Left. So that would be all the numbers that go from here all the way. So those are all the numbers that are less than b. What is that interval? Starts at where? Negative infinity up to b, right? Okay, all the numbers that are less than b. What is the smallest number that's less than b? How far can we go to the left? Forever, okay? From negative infinity to b. Negative infinity or infinity will always have a parentheses. Why is that the case? Why do we have a parentheses around negative infinity? It's not an actual number, it's a direction. So I can't include it, okay? If the minute you think you found the smallest number there is, all I have to do is subtract 1 from it and I've found a smaller. So you'll never get there. And what goes around b in this case? Parentheses, okay? How does that differ than the next one? What is the next one? Yeah, negative infinity to b with what? A bracket around the b, okay? That's the interval from negative infinity up to b. And what does the next one, in English, what does this mean? All the numbers that are greater than equal to a, okay? So if I had some point a, it would be all the numbers that are bigger than a. What is that interval? It's a to positive infinity, okay? From a to infinity? Question? Oh, sorry. This one was greater than, so yeah, let me back up. These were all the numbers that were greater than a. So from a to infinity, parentheses, parentheses. And then the one next to it is going to be every number from a to infinity, including a. So that one has a bracket. Okay. What's the next interval? What's the interval? Yeah, it's just negative infinity to where? Positive infinity. Always a parentheses around negative infinity or positive infinity. So in interval notation, what does it mean to say all the numbers that are less than or equal to 5? What is that interval? Numbers less than 5, what is that? It's negative infinity up to 5, right? What goes around the 5? A bracket, okay? All the numbers greater than or equal to negative 2 and at the same time less than 10. So these are numbers between 2 and 10. Yeah. Bracket, parentheses. Yeah. Bracket, parentheses. Those are all the numbers greater than or equal to negative 2 at the same time less than 10. All the numbers greater than or equal to 0. What is that interval? Yep. Greater than or equal to 0, so that's all the numbers from 0 to infinity. Okay. Now with interval notation, it's always the smallest number on the left and the biggest number on the right. So this is not, I would not write this like this. We do not do, it's not infinity to 0. Why do I not write infinity to 0? That's going from right to left. We're going from left to right. So it's always the smallest number and then the larger number. Okay. What about numbers that are less than or equal to negative 2 or greater than 10? So if I had negative 2 and a 10, what does it mean to be less than or equal to negative 2? So if I had negative 2, I would be shading which numbers to the left or right? Numbers to the left of negative 2. And then with 10, numbers that are where? To the right of 10, okay? How many intervals did I just draw here? Yeah, what is this first interval? Negative infinity to negative 2. What goes around the negative 2? A bracket, okay? And then mathematically, we use this union symbol to mean or. So it's that interval or what's the next interval that goes here? This is what? 10 to what? 10 to infinity, okay? So this is the interval from negative infinity to negative 2 or 10 to 0. What about this interval here, less than 0? Yeah, negative infinity up to 0. Yeah, so the question Lily asked, can you do either? Okay, is it possible for a number, let me ask you, is it possible for a number to exist right here and at the same time be over here? Can that number be it cannot. So it would have to be either in one place or the other. That's all this means. This interval or this one, okay? So it is not possible for a number to be in both places, but it would have to be either this one or the other one. Okay? What about numbers that are greater than 0 and at the same time less than or equal to 5? So you can draw 0 and 5. What does it mean to be greater than 0? How would I draw that? Shade to the right. What does it mean to be less than or equal to 5? What is that interval? That interval is from where to where? 0 to 5. And you can copy, if you're drawing the number line, this open circle means what in interval notation? Parentheses, bracket, okay? From 0 to 5. Okay? Pretty straightforward. Let's pick on a couple of people. We'll say Maddie. So, favorite food or foods? Oh, did I do that wrong? Sorry. I'm having a blank here. Help me. Help me. Sydney, sorry. Back up. Sorry about that. Favorite food or foods? Chocolate. There we go. That's a good one. We'll move around the room a little bit. How about Mr. Gavin? Okay, you got to do better than that. I can't just. Ice. I take it I'm not going to get much more out of Gavin today. Wyatt, sir. Chicken. And let's move back. Austin, what do we got? What do we got? Strawberries? Okay. Okay. So, what we have, guys, what I have defined a relation. So, a relation is just association between two data sets. One data set is your first name. The other data set is a list of foods. Okay, so I've got a relation between these two. Okay. So what we have, the input was your name. So the input, I came up with your name, and the output was you coming up with what? The food. So what we would say is, this was, over here, this was the domain. And this was the range. So domain means input, range means output. So I inputted your name, you gave me the output of a type of food that you like. Okay, so let's move a little bit further. And let's do another relation where I have a name and the number of years you've attended Woodward. So for example, let's just have a few data sets here. So if I said Amanda, number of years at Woodward, 5, okay? And if I had Lily, 10, okay? Let's go around the room to, we'll pick on Aiden. 3, okay? So the domain of this function is Amanda, Lily, and Aiden. Those were the 3. The range of this function is what? 5, 10, and 3, okay? What we will say is the definition of a function is a relation such that every member of the domain only gives back one value of the range, Okay. Now, would it have been possible for Amanda to have said, I've been here 5 years and I've been here 12 years? No, it's not possible. There was only I was only ever going to get one number out of this question. If the question had been, you know, you know, if I had asked you what are your favorite numbers, you might have come back and said 7 and 11. That wouldn't be a function because you're giving me two different numbers, okay? So in this case, every element in the domain only gives me one value in the range. This is a function, okay? Because every element here is only mapped to one element, okay? So the way this one is set up, it really wasn't set up to be anything but a function by definition. So let's talk about what it looks like for something to be a function. One way we can look at a relationship is we can look at a relationship graphically. So what is the domain here? What numbers are in the domain? -3, -2, -1, 0, 1. Is this a function? The definition of a function is every element in the domain, it only gives you one number back for the range. How many numbers do you get back from this one? 1, 1, 1, 1, 1. Is this a function? Yes. This is a function, okay? Let's look at the next one over here. -3, -3 gives you 4. -2 gives you 0. -1, 2, 0, 1. Is this a function? This is a function. This is a function. Every element in the domain is only giving me one number back for the range. Now, let's move into one that's not a function. So this one right here, this is not a function. Why is this not a function? Yeah. -3 can't return a 1 and a 2. If it returns two values, this is not a function. So this is not a function. What about the last one? Definition is every element in the domain returns only one value in the range. What's keeping this one from being a function? Yeah. This element of the domain does not return a range value. So this is not a function as well. Okay? So you can look at these mapping diagrams to tell if something is a function. The other thing I can do, I can give you points on a graph. Okay? So let's look at this. What is the domain of this relation? Yeah, 0, 1, 2, 3. Those are the set of all x values. X values are our input. What is the range? Yeah, 1, 1, 1, 2. I don't have to write. If you wrote down 1 3 times, no problem, but you don't have to. Those are the only values I'm getting back. Is this a function? Yes. It is a function because every element in the domain is only giving back one unique value in the range. Okay. Let's look at the next one. What is the domain of G? Yeah. This is just copying down numbers. Okay. This is pretty easy for a Monday afternoon. All right. That's the domain of G. What is the range? Yeah. 2, 3, 0, 5, 1, 2. 2, 3, 0, 5, 1, 2. Okay. Is this a function? Okay, what I'm looking for is every element in the domain is only giving me one value back in the range. Okay? -5 only gives you a 2. -4 only gives you a 3, and so forth. This is a function. Okay? So every domain element only gives me one range value back. Now look at the next one with H. What is the domain of H? Yeah. Okay. And the range is 2, 3, 0, 5, 1, 4. Okay. Is this a function? No. Why is this not a function? Because -2 is giving me two values back. I get -2, 0 and -2, 1. Okay, so this is not a function. So what your clue is, when I'm looking at this in set notation, I'm looking to see for repeated what values are going to be my clue this is not a function. Yeah, repeated x or domain values. So the minute I see a -2, occurring 2 times here, that tells me this is not a function. Yes. Right. You can have repeated range values. That's okay. It's when you have repeated domain values that you have a situation that is not a function. Now, the other thing you can do is I can give you a graph, and you can inspect the graph and tell me whether or not this is a function. Now, the domain is a set of all what values? X values, okay? So I want to find the domain of this function. So to find the domain of this function, I have to see what X values are being displayed here. Okay, I travel from left to right. Does this graph have any X values over here? What's the X value right here? So if I'm here, this function has no values. As I travel from left to right, I don't see any values until I get to where? -6. Okay. Now, is -6, I look at -6, is that included or not included? It's not included because of this open circle here. So it tells me that that's where my domain starts, at -6. Now, let's keep traveling from left to right. It looks like as I keep traveling past -6, I'm seeing values of this function, and then something happens at -2. Okay, there's an open circle, but what's up here? Closed circle. So I do see a value. And then if I keep traveling, I see values on this graph until I get to where? +4. So the domain of this function is from -6 to 4. Why do I have a bracket on the 4? Yeah, it's a closed circle. So the domain of this function is -6 to 4. Okay? Now, to find the range of this function, anytime you see the word range, that's the only time in math you are allowed to go travel on the y-axis. Everything else is the x-axis. So I come down here. Do I see any values for my graph down here? No. I don't see values until I get to where? -2. Is that included? Yeah, okay. Now, if I keep traveling up the y-axis, I see values of the graph continuously. I see that until I get to where? 6. And what goes around the 6? Parentheses. That's the range of this function, okay? So we'll be doing more of that. Finding the domain in the range means looking at the possible values of x versus the possible value of y. Is this a function? Yes or no? Okay, so they're saying no, you're saying because of right here? Okay, so at this point, is this point included on the graph? This point right here? No. Is this point included? Yes. So how many values did I get back at -2? One value. Now if this had been this is not a function because I'm getting 2 values. But because it's open circle, this is a function. Now this brings into something else. Graphically, there's a test you can use to prove if this is a function called a vertical line test. Why do you think it's called the vertical line test? Yeah. If I draw a vertical line there, it only crosses the graph one time. So the point that was in question was right here. But that only touches the graph once because this is an open circle. So I can draw vertical lines all day long and it's only touching the graph one time. So that makes this a function. So this is a function. Okay? So let's look at the next one. First off, is this a function, yes or no? Yeah, you know this is not a function because I can draw a vertical line and it's going to cross the graph more than one time. So that is not a function. What is the domain of this guy? 1 to what? What kind of enclosures? Bracket to bracket. So the way I got that was if I start traveling on the x-axis, there are no values until I get to 1. I keep getting values until I get to 4. Now with the domain, there are no values in this graph until I get to where? 1. So what is the domain of this? The domain is what? 1 to 5. And bracket, bracket. So that's the range of this relation, okay? So we established this one is not a function. So look at this one. Now, this is a parabola. The arrows mean it's going to keep on going forever. So this is going to keep on going down and out forever. So what is the domain of this guy? Negative infinity to infinity. Because this is going to keep on going down and out. What is the range of this guy? No, the range, you always start down here. So if I start down here, this is negative infinity. I will get y values until I get to where? 4. So this range is from negative infinity to 4. Always a parentheses around infinity or negative infinity, but what goes around 4 here? Bracket. Is this a function? Yes. Okay. This is a function. And one more, and then we will take a little game break. Okay. So, to find the domain of this guy, domain travels on what axis? X. So, are there any values over here? No, I don't see values until I get to where? Negative 5. What goes around the negative 5? Parentheses. Okay. Now, I see values of this graph until I get all the way to 4. Okay, there's a value here and a value here, and then okay, yeah, it stops. Okay, so I would have been continuously, so that goes all the way to 4. It includes 4, and then if I keep on traveling here, I don't see any values. What's the other value that I see? 6. So it's this. Every number between negative 5 and 4, or the number 6. Okay. So it takes on every value starting at negative 5, not including negative 5, up to 4, including 4, and then it could be the number 6. Yes. If there were a value for 5? Yeah, so if the graph had this point, like that, yeah, then it would be U5 and then U6 in that case, okay? Now, the range. What's the range of this guy? Negative 3. What goes around the negative 3? Parentheses, up to what? 2. Bracket. Mm-hmm. Yeah, there we go. So the range on this guy, there were no values until I got to negative 3. I had values continuously up until I got to 2. And then I jumped. I only saw the value of 3 and 5 were the only things that were left. Is this a function? Why is it not a function? It's not a function because what happens right there? So that is, now if you think about it, what is this point right here? What is this point? This is the point what? 4, 2. What's this other point? 4, 5. What do you see that tells you that's not a function? You see repeated what? Repeated x values, yes. It doesn't matter, U3 versus U5. All this means is or. It's every number between negative 3 and 2, or it's the number 3, or it's the number 5. Okay? So whichever happens there.